This video is for section 9.5, the effects of changing dimensions proportionally. You see the state standard written here, as we've told you. We're kind of tightening up our content here and trying to get the important stuff to you in the most efficient way possible. So, we're in fact, the problem itself that we're going to look at today, pretty basic. And honestly, I put triangle in here, but it could be anything. In fact, probably, spoiler alert, probably won't be triangle when you get to your assessment. But we're looking at any triangle, and we're multiplying the base and the height by 3. And what's the effect going to be on both the perimeter and the area? And then there's a second question saying, given that the area of the original triangle is 40 square feet, what would the new area of the bigger triangle be? And the advice there is to use your new scale factor. So at this point, I want you to pause your video. We're going to go on and see the answers here in just a little bit, but I want you to try this problem based on what you looked at in the presentation. Again, we've got ourselves a triangle, and we're just changing the base and the height, and we're making them 3 times bigger. What effect does that have on the perimeter and the area? You should have already gone through the presentation and looked at possibly any practice problems that you want, and then this is kind of getting you ready for us to assess it. So pause your video. I'm going to pause here for a couple seconds and let you try to answer all 3 of these. What's the scale factor? That's the SF here. What's the scale factor of the perimeter? The scale factor of the areas between the original smaller triangle and our new larger triangle, and then answer this question down here. Hopefully you paused your video and answered those as best you could. Here are your answers. The perimeter, if everything's 3 times bigger, the perimeter is going to be 3 times bigger. Its perimeter is one-dimensional, and so if we increase the base and the height, make it 3 times bigger, it's simply going to be, the perimeter is going to be 3 times bigger. The area is going to increase by 3 squared. So if this had been, there's nothing magical about 3 and 9. The only thing magical is that 9 is the square of 3. So if it would have said 5 times bigger, then the area would be 25 times bigger. If the perimeter was 10 times bigger, the area would be 100 times bigger as we look at this. And then the second question, using that, so that the original triangle had an area of 40. What's the area? And I forgot to change this. I went and changed the problem in the book. My apologies. This should say triangle. It'll be changed in your presentation, but I'm gonna kind of push ahead here with our video. The new scale factor. So again, we're talking triangles here. It would be 360. If the original one had an area of 40, the new one is going to be 9 times that. 9 times 40 is 360. If you learn a little better by visualizing, let's take a look at a picture. Kind of drew a crude picture here. This triangle does have an area of 40 square feet. There's a bunch of ways to get triangles with an area of 40. I just happen to pick this. 4 times 20 is 80, divided by 2 is 40. Now we're going to triple everything. So this becomes, and I don't know if these are drawn to a scale. I did my best. 4 becomes 12, 20 becomes 60. So this triangle has a height and a base that are 3 times bigger than this one. And now its area is going to be 360. 12 times 60 divided by 2 or multiplied by 1/2 or 0.5. Think of 0.5 times 12 would be 6. 6 times 60 is 360. So here's one example of what you just saw in terms of that. So again, questions, make sure you're in communication with your classroom teacher. Go through the presentation. This video was primarily to get you ready for the assessment that is soon to come.